Hey everyone, this is Mrs. Slauson, one of the Algebra 2 teachers here at Eagle Crest High School, and I will be going over the first attempt of learning target number 9, properties of logs. So hopefully this is similar to the way Mrs. Hampton shows you, but I will be showing you what I taught my students. So in the first 3, when the directions say expand the log, instead of seeing one log, I actually want to see multiple logs. So 2 or 3, just depending on how the original problem starts. So the first thing I like to do just for a while is just kind of ignore this log because it's something that I don't need to focus on right now, and look at the fact that what's there is x to the 4th divided by 4. And what I told my students is that a division symbol looks really similar to a subtraction symbol and vice versa. So what I'm going to do is take that division symbol and I'm going to turn it into a subtraction symbol. And then what I ask my students now is how many times do I have to write this log 2 that I had ignored for a little while? And I have to write it twice. Once for the x to the 4th, and then once again, and it's not divided by 4, hello, it's divided by y, just realized that. And then once again for the y. And then anytime I have an exponent in my expanded log, I want to move it to the front of its own particular log. So it will turn into a multiplying. And now I have log 2 of base x minus log 2 of y. And now that's fully expanded. So that was a really worked out problem. As I progress, I might not do as much detail. So the next one, again, what I'm going to do right now is just ignore this log base 9. And when I see u to the 4th times v to the square, v squared, sorry, again, I remind my student that back in the day when a multiplication symbol used to be an x, that looks really similar to an addition symbol, and the other way around. An addition symbol looks a lot like a multiplication symbol. So if we want to put a tiny little x there, now what's going to happen is when I start to expand this, that multiplication symbol will turn into an addition symbol. And now I'll write the log 9 that I forgot twice. But this time, instead of putting the 4 as an exponent, I'm going to go ahead and just move it to the front. Oops, I forgot my little base 9. And then in the other one, log with my little base 9 with the v, and then the 2 will move to the front of that log, and now I've expanded this. In the last problem, it looks a little different because right now we have a square root. So just a reminder that if you have a radical, you will have an index number, so we can call that m. You will have an exponent number, an n, and you can rewrite it as an exponent. That's a fraction. It's called a rational number. So if you just kind of take a moment and look, where the n and the m goes as far as the fraction piece, then what will happen here is when, again, I'm going to ignore this log, and I have a square root of b, that there's an invisible 2 and an invisible 1, and that I could actually just write that as b to the 1/2 power. And now this addition symbol will turn into, this multiplication symbol will turn into an addition symbol. And now I can add the log 4 that I ignored with each piece, except the 3 will now go into the front. And here goes the b, but let me put my little 4, and the 1/2 will go to the front. So those are my expanding problems. All right, in the next half, and this is actually the more important section, is instead of having the multiple logs, I want just one log. So what I'm going to do first is the thing I did last year, and I think you can see that best in this problem. The very last thing I did in problem number 1 is I took the exponents and moved them to the front of their log. So I'm actually going to undo that first. So I'm going to take this 4 and I'm going to move it back as an exponent. The next thing I like to do is just kind of ignore the logs because it's a lot to look at. And now what I'm seeing is x minus y to the 4th. And now that subtraction symbol will become a division symbol. They don't like division symbols in logs, they like fraction bars. So I'll write it as x divided by y to the 4th. And now that natural log that I ignored can be written just once in front of it. If you want to put this in parentheses, you can, but it's also totally acceptable to not. So on the next one, the first thing I'm going to do again is just move this 3 back as an exponent. I'm going to ignore these logs now just so I can focus on the fact that it's x minus y minus z to the third. And now this subtraction will turn into division. And sometimes students get confused as to where things go in the fraction bar. So when I start looking at this, I'm going to look at it left to right, and anytime I say divided by, I'm going to take that answer and move it down into the denominator. Look at all those D's. So x, I didn't say anything about divided, so that can just stay in the numerator. Divided by y, so divided is going to go down in the denominator. And then I say divided by z cubed, so divided can go down in the denominator. And now that log with its base 2 that I ignored can go right there. Again, if you want to put parentheses around that argument, you can. This time I won't, just to show you that that's okay. Last problem, let's move 1/3 back. Let's move the 2 back. And now, just ignoring everything else, I see x to the 1/3 plus y squared plus z. All that addition will turn into a multiplication. But now I'm going to revisit what I showed you in problem number 3. If you see an exponent that is a fraction, then what we're going to have to do is rewrite it as the radical. So I'm going to get my check mark set up, and then I'm going to come back up here and just kind of look where the letters go, and that means the 3 should go here, the invisible 1 there. You wouldn't see the invisible 1, so the way I would write my final answer is I would put the cubed root of x times that y squared times that z. You don't have to have those multiplication dots, but when you have a radical, I think it looks a little messy if you don't. And then this is now condensed, and that is it.